Hello, 5th period. My name is Rodrigo Valenzuela.
Alejandra Lopez.
And Martin Somoza. In this video, we'll be talking about horizontal velocity.
Velocity is your vector quantity. It tells you the speed and the direction of an object in motion.
The equation is velocity equals to displacement divided by time. The SI unit for velocity is meters per second.
In horizontal motion, there are three types of velocity. There are average velocity,
Constant velocity.
And instantaneous velocity.
Average velocity is the rate at which displacement occurs.
In this case, velocity can be positive or negative.
To find average velocity, we need to divide the change of displacement to change of time. To find average velocity, we need to use the equation delta D over delta T. In the tire we threw earlier, we figured out the values of initial displacement being 3 meters, final displacement being 5 meters, initial time being 3 seconds, and final time being 7 seconds. Let's use these values and plug it into this equation. Now that we have the equation, let's find average velocity. The change of displacement over the change of time. This leads us to having 2 meters over 4 seconds, giving us a total of 0.5 meters per second.
Constant velocity means both constant speed and constant direction. To go in a constant direction means to go in a straight line. An example of constant velocity is when the car is moving at a constant speed in a straight line. To find constant velocity, we need to use velocity is equal to distance divided by time. In this situation, we are giving 75 meters and the time is 4 seconds. And as I said earlier, we are looking for velocity. Okay, so we are going to go on to the problem solving, and you plug in the distance, you plug in 75 meters in the numerator. The denominator, you plug in 4 seconds. You plug that in, and it is equal to 18.75 meters per second. The reason that this is a constant velocity is because the car was going at a constant speed in a straight line.
Instantaneous velocity indicates the velocity at every instant in time. To find instantaneous velocity, we need to calculate the limit of the average velocity as the time interval becomes infinitesimally short or as the time interval approaches 0. Let's use Martin as an example. As he rides a scooter, we need to calculate his change in displacement for different time variables.
Alright, so what we have here is, what I've done is I put together a table with the data that we collected from Martin riding his scooter. So this table consists of the change of time, which is within the interval of 0 to 5 seconds, and with this change of displacement, which is from 0 to 50 meters. And to find instantaneous velocity, we need to use this equation. As I said before, we need to find the limit of the change in displacement divided by change in time. So by using this equation, we can use the values in this data table to determine the instantaneous velocity. So what we need to do is we need to choose two different time intervals consecutively. So what I chose the time interval between 2.5 seconds to 1.5 seconds. And that would give us a change in displacement from 10 meters to 25 meters. Alright, so by using these values, we need to find instantaneous velocity. And so the solution would be velocity is equal to limit to the change of time as the change of time approaches 0, and then the change of displacement divided by the change of time. So then this equation changes into this final displacement 2 minus initial displacement divided by final time minus initial time. And so now let's plug in these values into this equation. So then 25 meters minus 10 meters divided by 2.5 seconds minus 1.5 seconds. And so when we simplify this, we would come out with 15 meters divided by 1 second, which would equal 15 meters per second. And that is our instantaneous velocity.
Breathe it in. Are you guys done? Are you guys done being little kids? Seniors?
Yes.
About to graduate?
Direction of an object in motion.
Don't cut it. We'll just cut it off from the edit. Alright.
I just touched my face.
Alright.
Let's use Martin as an example as he rides his scooter. We need to calculate his change.
Oh, right. Okay, Martin.